Hello there. Welcome back to the series where we're walking through the LLVM tutorial called Kaleidoscope, or it's actually called I believe it's called like making your first programming language front end with LLVM. And if you've been following along with the series, you've walked through 4 chapters and a half of this tutorial, which contains 8 chapters. I took a hiatus from this project, but I've decided to continue on with it and hopefully bring it to completion. As part of the hiatus from this project, another project that I worked on a few months ago was a programming language written where the parser and the generator was written in JavaScript, but it spits out LLVM code. So and I actually brought this project to pretty far. I put a whole bunch of work into this. Unfortunately, I didn't document this project with any videos, but if you are interested in looking at the source code, then have at it. This is the URL over here. If there's any interest in me making videos sort of showing how this code works, please let me know in the comments, and then I may do that sometime in the future. For this video, I'm going to continue on exactly where I left off. Where I left off was we have actually completed half of chapter 5, and the first half was implementing if statements in the language. The second half, which I'm going to attempt now, is going to be implementing the for loop expression, which is gonna look like this, which looks kind of like a cross between a C++ for loop and a Python for loop. Maybe it's more like a basic for loop. In any case, we're gonna do this. Let's see where the tutorial takes us. Okay, first we're gonna need Lexer extensions for the for loop. I am not quite sure what this syntax means, honestly. Is this some sort of grammar that I haven't seen before? Did they use this syntax earlier? They kind of did. Wait a minute. I'm looking at the wrong version of this tutorial. That's why. This is the OCaml version of the tutorial. But I want the C++ version, not the OCaml version. Let me see. There we go. Okay. All right, we're good now. So if you're like me, you looked at that syntax, you got a little confused because you haven't seen the OCaml code before. That's why. So we're gonna stick with the C++ version, although if you prefer OCaml, then by all means go for that. So the first thing we're gonna do is add the definition for token, a Lexer token for the for keyword, and we'll add a line of code to recognize that. So that one of the lines is over here, so let me see, toke 4, I would assume. Yeah, and in, so we're gonna have an in keyword as well, which is part of the for loop statement. And then later on in this cascading if statement, this, I don't know if the word cascading is correct, but this series of if statements, we're going to add 2 of them. I'm just going to copy it because this is all very self-explanatory, and I don't feel like I'm getting value out of typing it all out. In general, if you've seen my walkthroughs, I prefer to type things out if I think I can learn something from that process. Okay, now that we have the lexer, we're going to add a parser component to this. Is this the part? No, this is the AST node. We're going to add an AST node for the for loop expression. That's what we're doing. So we're going to go down to the section where we have all of these AST nodes. The AST nodes are classes, each of which postfixed ending in AST. So we'll add one maybe close to the bottom here. We have functions, maybe after the if statement. Where's the if? Okay. Yep. Okay, so I'm gonna, this part I'm gonna sort of copy it over. I'm gonna type out the statements. I'm gonna move this over a little bit. Okay, let's go for this. Maybe make this font a little bit smaller. There it is. All right, let me try this. So class for expr ast public, it extends the base class for the expr ast for the AST nodes, which is called the expr ast. And then we're gonna have a var name as the string. I believe this is like something like for n equals 0, comma, n, what was the syntax again? And while, this is while, oh, let's go with I. So for I is 0, while I is less than 10, this is the amount to increment, I guess. And then you say in, and then the next statement can have I inside the scope. I think we can do something like this. So this var name, I believe, would have been this I, or whatever you chose to name it. Okay, so this is the var name. I'm gonna have a unique pointer to an expression AST. One for each of these parts, and each of these parts is there's a start and an end. I think this is the start, this is the end, step is this number here, and the body would be this here. Okay, so we have an AST node for each of those chunks. And then we basically, okay, I'm not gonna type these out because it's very repetitive, but essentially what it is, listing out every instance variable that we have previously defined as a parameter of the constructor, and then we're gonna list all of them out again as part of this static initializer list. I believe that's what they're called, and this is kind of tedious as well, so I'm gonna type, so this is basically var name. I believe that references this one, this var name references this one, whereas this var name references this one. Both of them happen to be the same name, which is quite confusing. And then the next part, we're gonna have to use standard move, because this is a unique pointer. A unique pointer is something actually during the hiatus I've learned a little bit more about. So hopefully I can speak to it a little bit more now than previously. A unique pointer is a pointer where if within the body of some code you have a pointer to a particular object in dynamic memory, also aka the heap, then that pointer is the only pointer that's allowed to point to that object. As in all other pointers to that object in other scopes of the code are invalid. But because of that, if you want to pass this pointer to another variable, or you want to pass this pointer to as a argument of a function, because you want that function to have access to this object in the dynamic memory, well, you have to invalidate yourself to make the argument or the other variable, the other pointer that you're passing to, valid. So that process of that transference, the transfer of the validity of the pointer, happens using the standard move method, which is saying whoever passed their unique pointer into us. Oh, I just noticed I misspelled this, so I'm gonna fix that. So whenever we're saying like new for x per ast, and they're passing in this, well, first they're passing in a variable name, and then they're passing in this x per ast, and then dot dot dot. So this is a unique pointer, and from the scope of this line, this unique pointer is going to be valid in this scope. But once it gets passed in, it has got to be valid in the scope of the constructor for this stuff to work. So they will actually have to move this thing. I think they will actually have to type this standard move here as well. But we'll also have to type the standard move in the initializer list as well, which actually is, I'm not totally sure why we have to do it both here and here. If you know why, please tell me in the comments. By the way, thank you for everyone who has contributed in the comments, teaching me more about C++. So yeah, if you can enlighten me about like why I need to write standard move here when I'm calling the constructor, and also have to write standard move here in the initializer list, please enlighten me. So, okay, I don't feel like typing all of this out, so I'm just gonna copy the rest of this. Okay, and then finally, I'm going to do this code gen override thing, which I believe that's saying I need to override the code gen method that's declared in the base class. I want, when you call code gen, I want you to be calling my version of the code gen that's declared for the for x per ast class. And then I assume later on we're gonna have a actual implementation of this code gen method to come. Okay, so now all right, we're gonna implement the parser that will be able to recognize the new syntax and generate an AST node here. So let me find a good place to put that parser code. Why is this code formatted weird? Okay, I'm gonna put the parser code after the one for the if statement, I believe, or the prototype one, maybe. Where's the parser code for the if statement? No, there it is. Okay, this is the parser code for the if statement, so I'm gonna put this code right after it. And the parser is currently implemented as a series of static functions. Okay. Okay, so first we're gonna get the token, which again, is the convention of this code base is that before it calls this this parse whatever function, in this case the for statement, the for expression, it has already seen that there's a for token, so this assumes the next token is the for token, because whoever calls it has already determined that. So the first thing is we're just gonna eat the for token. And then we're gonna say the next token after that, which is the current token, we're expecting that guy to be a token, an identifier token, which is, who is it? Oh gosh, I'm gonna split my editor here. There it is. Okay, so for here, okay, so this guy is supposed to be an identifier token, this I here. So this so then what this code is doing is saying, well, if it's not an identifier, then I'm confused, I'm gonna error out. Okay, and then I'm gonna log, I believe I implemented the log function in a slightly different way from how they did it. So I'm gonna reference my own code for how I do this. I just call log error. Okay, expected identifier after for, yep. And I'm just gonna return null pointer separately. I disagree with how the author wrote this thing, so I decided to do it differently. So now we're gonna try to get the identifier now, which is actually just, there's a global variable called identifier string, as I remember, which would already contain that identifier string. So and then we're gonna eat that token, and by eat, we also, by eating the token, we also advance the token cursor to the next token in the stream. So now that we've advanced the cursor, the next token we should be looking at is the equals token, because again, it looks like, I should probably write that here. So again, the syntax looks like something like this. The syntax should look something like this. So we've parsed the for there, and then advance to here, and then we get an identifier, and then we're gonna advance, and now we should be getting this equal sign. So this is just saying, hey, if it's not an equal sign, we have a problem. gonna eat it. Okay, after that, we're gonna parse this 0 here, and that is actually going to be the start expression. Okay, so and if we are unable to parse that start token, then we're gonna return null pointer to signal a failure. Otherwise, we keep going. So now I'm gonna assume that whatever parse expression that the reason we're parsing expression, even though this is only a number, is because this could potentially be like a more complex expression, like a plus b, right? So that kind of thing need to be dealt with. So we call out to parse expression to parse this initial value or the start value for I, or whatever that variable's name happens to be. And then we're gonna say, okay, we're gonna try to match a comma now. And if we don't get a comma, again, that's a problem. So we'll print this error statement and then return a null pointer to signal that it didn't work. And then we're gonna advance this token, and then now we're advanced to here, and we should see another identifier. So that's wait. Oh, the end. So we're parsing an expression. So this entire thing is going to be the expression which signals the end. Okay, that makes sense. And if we don't get the end, then we're gonna again return a null pointer to signal that it didn't work. And then the step value is optional. So this, I guess this last bit is optional. I guess if they don't supply it, we're gonna assume it's 1 or something. Yeah, probably. So in any case, we're going to we're gonna expect that this comma exists, or I guess in this case is like if it doesn't exist, that's okay. We're gonna so it's like there's a, because it's optional, we're not going to require that it be there. Therefore, we don't log the error if it's not there. And if we detect that it's there, there's a comma, then we try to parse this step value, but they're saying this is optional, so they could have written it like this without the comma 1.0. But it would be wrong to have a comma but no number in there, however, which is why we still have this check to see if they put a comma here but we're not able to parse the expression, then that's a failure as well, and we signal that with a null pointer. Okay, so I'm gonna say get next token. This is to advance past this comma to the next thing, and then we're gonna call parse expression to parse what the step is, and if that didn't work, we're gonna return a null pointer. Now we're expecting this in keyword now. And we're gonna say if it's not that, that's a problem, and we're gonna error out. And return the null pointer. Otherwise, if everything is fine, we're gonna eat the token, which advances the token pointer to the next thing, which will advance past all of this, and the next thing should be the body of the function, which is just one expression. So again, we call parse expression to parse that. So if there isn't a body, we're going to return a null pointer. Now finally, we're ready to create an AST node that represents this entire for statement. And yeah, you can see we need to do these standard colon moves here to move each of these start, end, step, and body. They're unique pointers. So we need to do this move, which invalidates the variables here, the pointer variables here, invalidates them and makes the pointers within the class valid. So that's what's happening. So we're going to make a unique pointer, AST, and then we have an ID name. I'm going to standard move the start, standard move the end, standard move the step, standard move the body. And that's the end of this function. And now we need to hook it up as a primary expression. So there's this parse primary function, which has this huge, well, it's not that huge at this point. It could eventually it could get huge, but there has this switch statement that given what the type of the current token, it dispatches it out to one of these specific parser functions. So we're gonna add one for the for statement. They added it down here. It doesn't matter where you add it. I guess I'll add it as the second thing. So here we call the function that we just wrote here. And that's how it actually gets utilized. Okay. Now, I might want to try to compile this at this point. Let me see if it works. So I'm going to say build my lang.cc. And maybe this compiles, and if it compiles, or if it doesn't compile, then it will help me fix my syntax errors. So I think I forgot to get rid of this. I was just writing this line as an example here. Try again. My battery is getting low. Okay. Alright, we have some errors. Unknown type name std. Oh, I need 2 colons here instead of 1, so let me go fix that. Hopefully that's enough to fix it. Okay. A missing v table. Missing v table for this some vtable is the thing you use for dynamic overriding of methods, such as this one. So missing vtable is a missing vtable usually means the first non-inline virtual member. Oh yeah, we haven't defined we haven't defined the codegen method, and that's why we have this error. So perhaps the codegen is what we should do next. But I'm gonna stop this session here and implement the codegen in the next video. So I will see you over there.